Go ahead, Dave.
Well, welcome to everybody to the uh, Tangerine SDR Hamsci development chat. Looks like we have a number of new people, and so we'll go through the list. And so first on the list, let's see, is Nathaniel,
Thanks.
W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Things are going fine here in Scranton. We had a great DCC on Friday and Saturday, and it was good to hear all of the reports from the different teams on the personal space weather station. So I think things are coming along well. And I guess that's it for now. W2NAF, back to net.
Yes, I forgot to give my spiel, but most of my week last week was consumed with DCC, and I felt a wonderful relief on Sunday. So, anyway, next on the list we have Dan in for XWE. Go ahead, Dan.
Okay, thank you, Dave, and hello, everyone. Um, I really didn't accomplish a lot last week. I did watch most of the DCC, saw some really good presentations. I think I watched everything that was Tangerine SCR oriented, and I watched probably half of the other presentations. So it was really worthwhile. It was, I think, really well done. A few little problems here and there, but nothing that created any issues and nothing that couldn't be overcome on a second try.
Yep.
So anyway, back to you, Dave.
Very good. Yeah, George and I, the thing that we worried about most about was a giant crash where we weren't able to keep things going. Anyway, next on the list is Dave Witten, KD0EAG. Go ahead, Dave.
Hello, I'm here. I'm glad to have gotten DCC dealt with. It was a good meeting. I enjoyed a lot of stuff that was there, and I'm slowly trying to get back to doing things that might be useful, but not. I tried to create a couple of GitHubs today for hardware stuff. See how that works. But otherwise, not a lot of hugely exciting stuff to report. Back to y'all.
I'll have to differ with you, Dave. I saw a wonderfully exciting graph today from Jules. I think it was amazing.
Well, yeah, I wish I had collected that. It looked really good to me too. I don't have the critical expertise to say for sure, but it sure looks like we're doing the right thing.
And Dave, I was thinking about repurposing some of my work stuff to work on a graphing module. So maybe I can do that.
Well, that would be really nice. That would be a really nice project. People would love to see, at least some of the testing data, I'm sure.
Yeah. Okay, next on the list we have Dev. Go ahead, Dev.
Hello, good evening, everyone. So I had a good week last week. I'm continuing to work on my code to try to read data from digital RF source, recorded data, instead of USRP pictures device that we have source in the UHAS code. That is to try to read the detected signature of Chop Iron Sunday. And I have some issues while doing so, and if time permits, with everybody's permission, I will try to seek some suggestions on coding on C++, because I do not have as much I do not have much experience in C++. I'm just familiar with the language, so I'm trying to understand few of the lines. So if we have time, I'll try to take some of the time. this evening. Thank you.
Well, fine business, Dev. Voice level is just a little on the low side, so you might pump up your microphone volume just a bit.
Okay.
And next on the list, we have Bill Engelkey, AB4EJ. Go ahead, Bill. Bill, there's no voice.
Welcome to Zoom. Enter your.
All right. Com check. Com check.
I can hear you.
Okay.
Faintly.
All right. Sorry. Where you got sufficient audio? Okay.
If you can give it a little more mic volume, that would be good.
Okay. Let me see what I can do here. All right. Sound settings.
That's much better.
Okay. All right. Sound settings. All right. The camera is off, but I'll give you a report on my local activities. Oh, by the way, you see Cole Robbins in the list there. He is one of our students, and he is going to be working on the central control system host database and all of the stuff that goes with that. So we'll get a chance for him to introduce himself when we come around to him. Been pretty busy this week. I got, as you probably are aware, I got the Whisper uploading on the Tangerine localhost working, and tested that, ran it for several days, and been running a test, simulated 6 channels of ring buffer, that's spectrum data, 2 channels of FT8 and 1 channel of Whisper, and everything seems to work fine. That gives us utilization between 15 and 20% of CPU on the Odroid, so it seems to have plenty of headroom there. What I did today was I started porting the thing over to the Raspberry Pi to see if I can get everything to build on the Raspberry Pi. I'm about a third of the way through that. I got the Raspberry Pi to where I can build all the prerequisites for digital RF and get digital RF working. So I get digital RF benchmarks running on the Raspberry Pi 4. So that's the heavy lift. If you can get that working, you can probably get everything else working. So anyway,
Yes.
we're making good progress on that. Congratulations to all on a very successful DCC. A lot of good presentations and discussions, and was an honor to be a part of that. So back to Ned.
Very good, Bill. And you need to have your boat ready.
My boat is ready at all times.
So it looks like you have some rain coming.
Yeah, we are expecting. I cranked the antenna tower down to its lowest setting this afternoon because we're expecting to be a direct hit from this hurricane that's coming in, starting tomorrow afternoon and going into Thursday morning. So and the generator is ready and gassed up and etc. Yeah.
Well, good luck. So
Thank you.
next on the list, we have Cole Robbins. Please introduce yourself. Bill gave you a little introduction.
Hi, yeah, it's nice to meet all of y'all. I definitely talked to some of you last year on some calls with this. This is my second year on the project, working with Bill and Dr. Atkinson from University of Alabama. So yeah, like Bill mentioned, me and a few other students are working on the central control system. So learning a lot and working on the web server and handling all of that data on the back end. So yeah, it was good. I got the invite from Bill to see and speak with all of you tonight, and I'll just be kind of listening in.
Very good. And you too, be careful the next couple days.
Yeah, thankfully don't have to leave my room much with all these online classes.
Okay. Next on the list, we have David. This is David with no other. Are you there? In the participants list, it's D. David.
Dave's not here.
That goes back a ways.
You're really dating yourself.
Well, if David can't comment, we'll go. If you ever get your mic working or you want to comment in the chat, please do. Next on the list, we have David McGaw in 1920x1080. Go ahead, Dave.
Hello, everyone. Not too much to report on the project, though I'm working to continue magnetometer testing. I'm working on getting a good long cable so I can put the magnetometer outside and co-locate it with the Bardington analog flux gate that I have, and be able to compare data. And have to say I was very inspired by the DCC. I'd not attended one before because usually involves travel, but having it virtual was quite a treat. And there are a number of papers that I hope to follow up on, not the least of which is detecting earthquakes by ionospheric means. Back to net.
Very good. They're always full of interesting ideas and interesting people. So
yeah, I will point out that there's a piece in the QST this month on one and gone, as they call it. Very brief enhancements, and I've certainly been intrigued by it, running Whisper and FT8 and things like that, and I see it constantly. And now I have to wonder, what are the sources of all of those? I had assumed it was just meteors and such, but I guess there are a whole lot of other phenomena that we will be able to study once we have these personal weather stations out.
yes. Okay, next. So we have David Lewis. David Lewis, are you there?
Hello, good evening. Just reading your mail, seeing what's going on over there. Won't take up your time. On to the next.
Sounds good, David. Welcome, and please come back if you're interested. Next on the list is Gary, AF8A. Go ahead, Gary.
He just sent a chat there that says, sorry, no audio or video tonight.
Oh, okay.
Great job by all on the DCC.
Thank you. Next is James Wolford, KG4DSG. Go ahead, James. Mike, unmute.
Got me now?
Yes.
Okay. I've been lurking on the recordings for about a year. Spent the weekend at the DCC. I figured I'd dial in this weekend. Spent some time today at the GNU radio conference. Was really looking forward to both of them being in Charlotte this year, but it didn't happen. So I'll just get out and listen in and see what's going on. Back to you.
Very good. And let's see, next on the list, we have David KE5DPZ. We have a bunch of Davids.
Yeah, good afternoon, good evening. How are y'all? This is my first time on the net as well. Looking forward to learning a lot more. There's new into the hobby, and I live in a spot that in 2024 we're going to have a good eclipse viewing, and so it'd be nice to have a good scientific research station to go from. Anyway, I'm gonna let it go back to the net. Y'all have a great evening. I'm enjoying listening in.
Yes, please come again. And I know both Christina and Nathaniel will be really interested in your observations. So anyway, next on the list, they keep jumping around, so I don't want to miss anybody. Let's see. Next is John Frank, N9WLY. Go ahead, John.
Hello, everyone. I'm new to the listening list, I guess, and really enjoyed the DCC. It's great that it was online this year. My friend Tim Shepard directed me to the talks about the weather station, and I'm very interested, but I don't know how to help yet, so just listening. Thanks a lot. Back to you.
Well, fine, and you're welcome here if you find it interesting. And next on the list is John W4JKL. Go ahead.
Okay, well, I'm on an iPad, so hopefully everybody can hear me okay. Attended my first, can you hear me?
Yes.
Okay. Attended my first DCC this past weekend. I've read the papers over the years, and now I have been to one, even if it wasn't in person. And I'm just here to observe and see what you guys are up to. Back to you.
Very good. Welcome, and I hope you come back. Next on the list is Jonathan KC3EEY. Go ahead, Jonathan.
Hi, everybody. I just wanted to say thank you for a great DCC. It was a lot of fun. There were a lot of good papers. A special thanks to you and Scotty and everybody behind the scenes making it all happen. It was a lot of fun, and it was a really good DCC this year. So that's all I really have right now. Back to the net.
Fine business, and thanks. We're looking forward to what you are working on. Next on the list is Michael, AA8K. Go ahead, Michael. So no Mike, but Michael is always there. He's been around following lists that I've been on for years. So thank you, Michael.
Oh, wait, how about this time?
That works. Gotta just push the right button.
Too many ways to route audio. Great time at DCC and enjoying GNU Radio. Back to you, Dave.
Very good. Okay, next on the list, Scotty, WA DFI. Go ahead. WA2 DFI. Sorry, Scotty.
Okay, thanks, Dave. And yeah, just trying to recover from DCC. Nathaniel, I got my nap on Sunday, and Sunday was pretty much of a blowout day after the marathon, because I had irrigation Saturday night until about 1:30 in the morning. So Friday night, sorry, or Saturday morning. So I didn't have much sleep that on the second day of DCC, but lots of good papers and lots of good questions and comments. So had a good time with that. And this week I kicked off the magnetometer build. So we're going ahead with that. They sent the latest Gerbers over, and so about 3 weeks from now we'll have boards to test. The other thing I did is I didn't do it, but I got a notice back from Intel that they've succeeded in duplicating my problem with the RAM controller, and which is good news and bad news. They said on the Linux version of the software they see no problem, but on the Windows version they can't get it to compile either. So at least I'm exonerated because they can't get it to compile either. So they're working on a workaround for me. If they can't find it, I may be forced to go back to the other machine that is running Linux. And
yes,
I have no problem doing that. It's just kind of a nuisance to go back and forth between two machines because my CAD software for the schematics and things doesn't run under Linux. So I have to use two machines. It's a nuisance. But the other than that, it's not too bad.
Well, so, that also means I can help you.
Yeah. And actually, that's true because the FPGA licenses are free for this size FPGA. So if you're running Linux, you can load the Linux version.
That's right.
And but I'll warn you, don't load the latest Linux version because they tend to rush them out with bugs.
Yes.
So
I'm a couple versions back.
Yeah, he's going to have to tell me which version. I think he was using 18.1, and 18 is 2018.
Yeah.
And they have they released 4 versions of Linux in 2019, of which none of them actually all work right. And I don't know if they've come out with the 20.1 version yet, 20.0 or 20.1, but I'm using 20.1 Windows because they recommended that that's what I do. And then I did it and it didn't work. So now I've got to go back, and I'm hoping they're going to come up with an answer for me. If not, it's back to Linux we go.
Okay.
Did you expect them to come back with an answer at all?
Yes, they'll come back with, and the answer might be you have to use Linux.
Okay.
But they will come back with an answer. Yeah, they will.
Okay.
They're pretty good about that, and they're relatively fast. Usually they're much faster than I am. So, you know, they give me an answer, and then I'm busy doing things, and I get back to them a few days later. Or they may ask me again, well, did you get that message I sent? So they prompt me again. But this time I sent them a message. I actually sent them my file, my archive file. And I said, look, this is what I have. You try compiling it. And he did, and it got the same errors that I did. So that's good. At least I'm doing all the things that they said I was supposed to do, and I'm getting the same results as they are now. So if they can't fix it, then it'll be back to Linux, because they did say that they tried it under Linux and it did compile. So it does work there.
That's
so that
good.
definitely
Connie,
that is an out if we have to do it that way.
What's the name of the tool package?
It's Quartus 2, and the version, if you go on the Intel website, you can download any of the versions back to forever. But since I started at 18.1, and then when I got the timing files for the fast speed grade part, apparently they have to compile the timing file for the version of Quartus that I'm using. And I was using 18.1, and they assumed I was using 20.1. So they compiled it for 20.1. So then they said, well, maybe you should just upgrade to 20.1. Of course, every version that they upgrade, it breaks something, and you have to go in and go fix it. Well, in this case, it broke something, and I tried to fix it, and there was no way to do it.
Okay, so what version of the tool for Windows and for Linux do you think that the project should be using?
The project should be using, I believe it's 18.1 for Windows and 20.1 for, in fact, just a second. Let me give you the correct answer here before I misspeak, because I got the an email from them.
Tom, it's a really time-consuming download. It's a big chunk of molecules.
Okay.
So what does
And your point is?
Fine.
I think that's
so
par for
getting
the
the
course.
versions. So getting the versions agreed, we'll make sure we just have to download it once.
Yeah, it's
yeah, that helps.
it is a large download. Hey, why don't you go ahead, Dave, and do the rest of the rounds, and I'll look this up for Tom.
Well, then Tom's the next person.
Okay.
Okay,
Tom,
Scotty,
go ahead.
Scotty, go off into the palm trees and the beach there, and we'll catch the version on the flip side. Okay.
Watch out, the wind seems to be coming up.
I think
Careful
I'm
of the storm
Hurricane
surge.
Sally. So this picture tonight will look a lot different.
Okay, this was a wild week. The wildfire evacuation came to within about 1 mile of the house.
Oh my.
And we had
wow.
evacuees here one night. Their house burned to the ground. They do have a slab left, but that's it. So things were pretty tough. You've probably seen on the news how bad things were. I got a bug filed on GNU Radio. I found a build problem on the latest version, and that's pretty much about it.
Tom, are you on the east side?
Yes, east.
Okay. I
Yeah,
used to
east.
live in Medford, so I know my way around a little bit.
Yeah, far east side, and the fires crept up to the east side, but kind of changed direction and went northwest, and so the evacuation area was a mile away, but we avoided any big ash fall, no fires, so everything over here was okay.
It looked like between Talent and Butte Falls got it really bad.
Well, yeah, it was strange. Talent and Phoenix pretty much don't exist, or a lot of it doesn't exist now.
Yeah.
And it stopped in just before downtown Medford, but a different fire started up over by Eagle Point up towards Butte Falls, and that's an entirely separate fire. So
Yeah.
they had 2 or 3 fires merge into one in Phoenix and Talent, and then they had 2 new fires.
We saw time lapse of the Phoenix fire.
Yeah.
Where it showed it just all the buildings burning, and then the final picture was like pretty much the entire town was ash.
Yeah, the preliminary was, I think, 200 buildings and an uncounted number of houses. Pretty much the whole city was just about gone.
I've been thinking about you as I see the reports.
Yeah, so we're fortunate. Our air quality here is way above hazardous, so it's pretty much indoors activity only.
Yeah, and Nona's sister-in-law lives in Otis, which is up in the northwest, up by Lincoln City. And there's another small fire up there, and they are under evacuation. They're in Albany now, hoping that their home doesn't burn down.
Yes.
And I got your answer, Tom.
Okay.
Version 20.1, both Linux and Windows.
Okay. Very good. I'm sure that the time will come when the developers are going to have to do trial builds themselves and tweaks and things. And so it's good to have everybody on the team using the same version.
Yes, it is.
So you're saying the same version for both?
For both, right.
Oh, okay.
So Scotty, did you have your
So which has the bug? Sorry.
The Windows version.
But 20.1 is the latest in Windows but doesn't work?
Correct. And 20.1 in Linux does work.
Right. But you're using 18.1 in Windows, or you don't want to go back?
I'm using 20.1 in Windows now because they requested that I update. But of course, I'm under Windows. So, and it's ironic because at the office, which we just closed and I moved out of, my machine was a Linux machine. But at home, I have only one machine with 3 monitors and it's set up real nice. And so I'm running Windows 10. So ironically enough, I'm running the one that doesn't work. So
yes. I have noticed that the Windows one tends to be more stable, but you know, I've run Linux all
They
along.
came out with 4 versions in a row of Linux versions that had bugs, different bugs in them. And you know, my business partners tried all of them because he's a big Linux fan, so he won't run Windows. He runs Linux all the time. And so he, of course, loads the latest one, right? You think that the latest one is the best one. It's not like beta or anything. So he loads that, and it had some heinous bug that was just like a basic thing. It wouldn't run the platform designer or something. And I'm just going like, you know, do you test drive any of these things before you release them? It's like, how can you just not work out of the box and be completely broken and then not see that? But I guess it depends a lot on what other things you have loaded in your operating system.
Yes.
And I mean, they expect you, it turns out what I really think you have to do, if you really want it to be guaranteed to work, if they support Ubuntu, say 20.1, then you better get yourself a new hard disk and you better load a virgin copy with no other crap on it and just load their software and load the operating system, and that's it. And then you'll pretty much be guaranteed it will work. But
Well,
if you start loading any other stuff,
that's why they invented Docker.
Yes. Well, I think we're at the end of the list. Have I missed anybody? So we're up for open discussion.
I did have a question that I wanted to pose based on some comments that were made at DCC about the timing of everything. I wonder if we've really been setting expectations correctly, because it seemed to me, if I remember, and my memory is terrible, and so I don't know, but what I thought I heard was we're talking about having the data engine availability, say something like in January, but then I think Tom said that the GPSDO, the clock that we need, wouldn't be until after that in February. And can you really run the data engine without a clock?
Yes, you can. You can run it with an onboard clock. You just won't be, it won't be a high stability, low jitter, and there'll be no GPS because there's no GPS on board until you get the clock module that has one. So yeah, we'll be kind of stuck until that comes out. You're right. But there will be a clock because I wanted to make sure that we could run a low cost version with no clock oscillator, no clock module at all for those folks that don't need GPS and don't need very precise frequency control. And we'll have a reasonably jitter-free oscillator, but it won't be as good as you're gonna get with the clock module.
Okay.
Yeah.
I mean, I just want to make, we need to make sure that everybody who would like to participate in the personal space for the project and do ionospheric observations with, monitoring WWV, you can't really do that without the GPSDO level of accuracy. So we need to make sure that people are aware of that.
Yeah. Well, hopefully it won't lag too far behind, but as far as the progress that we've made on the schematics and things, it is behind the DE. So, and
yeah, the other thing we mentioned, the receiver was ahead of the DE, but of course, without a DE, the receiver doesn't do much.
Yeah.
And we're only waiting on the receiver because we want to make sure that we don't. We want to make sure it'll plug onto the data engine, and that we didn't make an error, and maybe have to adjust the receiver module. That we won't adjust the circuitry, but we might have to adjust the size or things like that.
Yeah. So so the receiver, during the presentations, it was announced the receiver was ahead of the data engine by about a month, and that kind of confused me a little bit. But I'm sure we'll straighten that out. We can do test and check out of the receiver without the clock module, but we cannot do characterization of the receiver without the clock module. So likely we'll find bugs in the data engine and in the receiver, after that initial thing. So I'm sure we'll have a spin there or two.
And we can't really test the receiver at all without the data engine, right?
Exactly right. I mean, there's no way to know if it's doing anything without the data engine. So, Scotty, you said that there will be a GNU radio load for the data engine for the receiver very quickly so that we can, because that's my plan to characterize the receiver is to use GNU radio to do that.
Okay. I really don't remember saying that, but if I said it, then okay. I think it's a good idea, don't you?
Well,
yeah, I think it was because
I've already done some experiments with the local host and the simulator and making GNU radio talk to the local host. I mean, so I hopefully we'll be far enough with the local host by then that was be able to say, okay, you got your data engine, you got your radio, plug it into this local host, and then you can do some GNU radio. I've even played around a little bit with I've got a prototype OOT module for GNU radio that talks to this thing. The last time I played with it was like 5 months ago, so I'm not sure what kind of shape it's in after all the other work I've done, but I'm hoping we can be far enough along with this to be able to use those tools to characterize the radio.
Okay, I see a fallback. Scotty mentioned he had FPGA code for HPSDR protocol 1. And if that's there, then we have an alternate approach for GNU radio.
Yeah.
And of course, having build stuff would be better, but at least we have a couple of ways we can get there.
Well, those things work. So many of those things work so much alike. I mean, we've intentionally made them close to compatible with each other. So, yeah.
So, Tom, are you thinking that we will hook the data engine directly up to a PC running GNU radio, or we would hook it to the local host and then have the local host talk to it, or would you run GNU radio right on the local host?
I'm not sure I can get adequate performance. Maybe we can. And And so the preference would be to stream the samples over Ethernet to a Linux computer in order to do the characterization. If that's not possible, then we can run GNU Radio on the local host. The intention is to use GNU Radio to capture the buffers and to look for spurious signals, noise level, overload, dynamic range, all of those things. And being able to capture buffers in GNU Radio should allow us to do a lot of those things in the characterization.
So you should be able to just take the HPSDR source block and mod it maybe for some of the new features we have. If we use Protocol 1.
Yeah, right now the current module uses Protocol 1. And if something spits out Protocol 1, we'll try to figure out how to deal with it. Like I said, if that's not available, we can go with what Bill has. It doesn't matter to me as long as I can get buffers of samples captured at 122.88. They don't have to be complete, but if I can get reasonable sized buffers captured and on the Linux machine, we can do the characterization by post-processing.
Yeah, but by the time we have the data engine, we should be able to do it both ways. And
Okay.
it would be fun to compare them, to see how they compare. Because the last time I tried this, which as I said, it was several months ago, it was when I had the simulator talking to the Red Pitaya. That was before I interfaced it to the Flex radio, and I was able to look at spectrum on the red that came off the Red Pitaya and was in the local host, and there was enough performance in the Odroid for it to run GNU Radio right on the Odroid at the same time it was running the local host. Because at that point, the local host is doing very little in terms of processing. It's just receiving buffers and passing them to wherever they need to go. So there's enough headroom, I think, to run GNU Radio as well. But we could also set it up to be accessible as yet a third computer that could, if you want to run GNU Radio on something really high performance.
Yeah, so you just run GNU Radio on a Linux box and plug it in instead of the single board computer, right? And then you have however much power you want to pay for.
That would be a way to do it.
Yeah. So those are all good options. I just wanted to make sure we're thinking of those now so that when the data engine and the receiver show up, we have a path to do the characterization.
And one of the main things I want to do is get with Dave and make sure we can do easy upgrades of the FPGA code right from the start, because there's likely to be bugs found and features added at a lightning pace on the FPGA. And so I don't want to make it hard for people to update. I want to make it a clickable, easy thing. So even if we sacrifice some security up front, because we don't need the cloud to be able to update the FPGAs. We just need to be able to have the user do it locally. So if we could put a repository up and have the people go download the image and then feed it into Dave's program and have it program the FPGA, it would be just a few clicks away and you get a new image. So it would be fast and easy. And you don't have to download Quartus 2 just to program the FPGA.
Can I make a suggestion? It could be a little off this, but
sure.
As far as managing expectations for users, I mean, I think it's always wise to not escalate expectations beyond reality too much, because people get upset or get bored and stop looking. But would it be possible to put something like a little progress graph for each of the major components just on the website, right? So when you first pull it off, at least kind of like a Gantt chart sort of thing, but not something that could be moved around and kind of indicate the current state and the target for having some things, each of the components working.
Sort of like a United Way fundraiser progress chart.
I suppose so. Yeah, with $1 billion or whatever it is. Yeah, but just some. I don't know how it would be best to do it, but at least people would look there and they'd see where things are.
Well, I
that
have
sounds
something
like
that for the software side. I showed that very briefly at DCC. I don't know if you remember, but the matrix going down the left column was the main software modules, and going across the top was the different milestones. We could emulate something like that for the hardware side as well, it seems to me. A
Yes.
good old project management tracking system.
Because right now, the way you get project management status is to check in here on Monday nights and ask.
Yes.
Yeah.
But I assume this is a job for me because I'm running the website.
And you're the master draftsman after those graphs you produce for DCC.
Oh, okay.
My experience has been that web-based status posting tools tend not to be updated regularly.
Well,
that might be true.
That's the hard part, is somebody has to keep after it.
So Dave, your job then is to make it really easy to update. I don't know how,
Okay.
but if that's possible. I mean,
So it's easy enough for Scotty to update it.
If it's easy enough for me to do it, then anybody can do it.
Well, one thing would be to have just put some standard, what do you call them, sliders, HTML sliders in a small table or frame, that could be, that at least people with some level of permission for the site could move around.
Yeah.
Well,
I'll work on that.
I'll bring up. Let me show you my screen.
Is that in your presentation?
Well, yeah,
Bill?
I'll bring it up right now. I'll let you take a look at it right now. Hang on a second.
Well, I have everybody's presentation from DCC, so.
I'd like to see it though.
Instead of using HTML, you could use a standard project tracker like Jira or ZenHub, and it would make the plots for you. But then everybody would have to update their tickets.
Do you see my screen there, which shows the status across the top? That something like this, and then there's probably some an equivalent way you could do something like this for the hardware side. Put all your major tasks or your major deliverables down the left, and your major milestones across the top, and just fill it up, fill it out.
And for the hardware, those tasks would be, pretty much fixed for all the boards, so you could do it similar to what you've done for software. And, that's just a table, Bill?
It's just something you do in Excel and just paste it in there. I mean, simplicity is the key here.
I understand. So, yeah.
Oh, anyway. All right. Now you've seen that.
So Dave, you and I can get together and figure out what columns we need.
Okay.
Sorry, Dave.
It's a good suggestion, Dave.
Yeah, I'll be happy to keep mine as the old project manager in me. Stakeholder management.
Okay.
I'll be happy to keep mine up to date on a weekly basis if.
Okay.
I mean, I don't have access to update things, but if I can send it to you, Dave, or KV0S or whoever wants to update it. So.
Yeah.
Dave, may I try to ask a few questions?
Sure.
So I mean to share my screen. So I would. It is related to GNU Radio and C++. I'm thinking through a situation in my course. So I'll help any suggestion going through it. Okay. Let me share my screen. So I'm running a course, shop.py. This comes from UHA's package, in which we try to detect. In this, we try to record chop in the data.
Yeah.
Being continuously received live through the USRP source. So I'm trying to, the source is defined here. So he defines chop record, and here is the source, USD USRP source. And there are other parameters here.
Yeah.
So I'm trying to change this source. Instead of the USRP source, I'm trying to have a digital RF source which contains a pre-recorded data.
Correct.
So I'm trying to replay the recorded data from the digital RF source instead of USRP. So let me try to run this chop.py, and which will prove few points which I would want to, and I'm debugging here to make a point. So that if I want to run that, like it requires me to give the output directory in which it sets the data as .out files. If I run this, sorry, for the first call, it still didn't work. And I've gone through the lines of this code for a good amount of time, trying to understand each of them. So we're at line 259 here. Let me see. I have the same file in another editor. I'm not sure which line it is repeating. Okay, because yeah. So this is 259. Seems the same.
Well, it's an import of a trace,
Yes.
right?
Mm-hmm. So it should have stopped here. So I'm not sure. So anyway, when it stops here, this is chopped. It's let us say T next. T next is right here, and chop is right here. So if I move out of debugging, if I press N, which means next, it will go to F name. My bad. I think it became a little late that I got timeout error, which was not the case when I was doing it. Okay, so I have to cancel it. So okay, let me try to do next. Okay, move sooner than next to 60. So it called F name, in which it was cor1.set the chirp.parameter. So this has run because set.chirp parameter is a function within a class here. The class is chirp_rec. This is the class, and within this there is a function set_chirp_parameter which is called, and like I had given some print commands which are printed here. Okay. So and CR1, so CR1 set_chirp_parameter is the it has been called, and we see the proof of it being called. And after it is called, there are two messages. This message is printed. So these come out of a C++ file in UHA's package, which is this. So these messages come out of here. So I'm trying to understand why those messages come. Okay, so I'll try to show the point where the message is being seen. I'll try to go. So this is done. I think we're good. So if I keep going, like it will run in a cycle. But right now I'm trying to understand these messages come. And I'm in the process of trying to understand myself, and if there are any pointers, any suggestions to move along the line, I'd appreciate that. I'm trying to understand it because these messages don't appear when I change the source. That is when I change the digital RF source. So there's a little more understanding here, like set_chop parameter is connected to CR1. CR1 is the class that was here. So this is chop_rec is CR1. That is defined, right here. CR1 chop_rec sr.chop So it is given all the arguments, the sampling rate, number of sounders, and the output directory. So it is defined here, and we call a function here, after calling which we get those messages. And I don't get these messages when I change the source. So something has happened here. I see these messages in the C++ code. And I'm trying to understand why these messages are printed, like what triggers these messages, essentially. Before going there, I would also like to see that the CDC, so this is the chop down convert C++ code, that is being defined as CDC here, which comes from UHA's package, uha.chop._convert. Right. And this is appended to a list, to an empty list, right here somewhere, append here, self.cr append CDC. So self.cr is an empty list within that function choprec. So within choprec there is a function, there is an empty list, and and that empty list is given this object uha choprec. And why is it important? Because I was calling this function, and during this function, self.cr is again called here within this function. And I want to remember self.cr already contains this uha.chop_downconvert CDC. So this self.cr is a list which contains uha's this code, see whatever it does, sorry, this one. So, and due to which I'm getting those messages. So I'm getting those messages while running this function, and in these functions there is self.cr, do something, set sub parameter as defined by these variables, self.cr, set fname, and self.cr, set timing, this. So self.cr is a list which contains CDC, where CDC is an object defined by this code in UHA's package. That's the summary. So where in this code do I see, like I have finished that level of understanding, and I'm getting in the process, and I apologize if this is a little more to something. Yes, hello.
Well, there.
Hello?
Go ahead. No, I'm not.
Well, essentially, this looks like tracer debugging information that you're storing in some space and then re-accessing it. And I see these things stuffed all over the code.
Yeah, but those imports are commented out?
Yeah, most of them are.
Yeah, but if there's one active somewhere.
Tom, do you know much about this kind of?
Yeah,
I know
there.
this isn't normal.
Yeah, right.
If you turn off the IP, if you just put a pound sign in front of IP db.set trace, it would be interesting to see what happens.
Yeah.
Just
so
right there. Right there. If that's the one.
Try to open a new terminal and we'll try to store it, okay?
Yeah, I'm thinking the same thing as you, Dave. And that may be something that's supposed to happen.
Yeah. Looks like
many of these
status monitor.
any of these values are made to be printed by me, like, because I was trying to understand the code line by line.
Sure.
Yeah. So I gave this print command, which we could have done with.
So it looked.
So now
There's your lag. One of the lags.
Yeah. Yeah. So in earlier part, I tried to explain like how this lag is coming. Lag is coming when this fname is called cr1.set chop parameter. cr is chop cr in chop record, and set chop parameter is like a function with this chop record. And while this function is being called, within there is self.cr, which is a list which contains chop down convert here, which contains that lag message. Okay. So for example, here.
Yeah. What seem to be the conditions that it's flushing standard out.
Yeah, so that's what I'm not completely following it. I'm here, like I'm here, I'm made to follow it. So I'd appreciate if there would be any suggestions or the directions to follow. I'll stop these. So this seems to be, for example, lag 1 is a float, 1.1, 1.5 float, second, USRP second, CPU time minus USRP time. So this is CPU, difference between CPU time and USRP time. And this is CPU time, and this is USRP time. And I tried to follow this, and these are being defined. And
Well,
I tried to.
Well, this whole thing is in an if waiting condition, which presumably doesn't execute this code unless this waiting flag is set. And that's why the lag appears somewhere above that. It must be that, and at the bottom of that block, waiting gets set to false. So somewhere above this block, waiting must, or in some other part, perhaps something that's going on in this while, if there's a background process, that waiting flag is perhaps saying that it's taking longer than it ought to do something.
So we have to remember in the C++ part of GNU Radio, the code is threaded. And so you're in a C++ module. Which function of the module are you in? Can you scroll up a little bit?
So we are at line 357 around.
Right,
so
but the whole thing's inside a block somewhere. The whole thing's inside of C++ block. Which
up.
Okay, stop. What?
Yeah, chirp down convert. No, further. Chirp down convert.
Down.
Chirp down converter. It's hard when it moves.
Yeah, it's I can't read it. It's just moving so fast.
I think it's inside this chirp down convert.
It looked like it was inside a
okay.
function.
So we're here. Let me try to go up. Okay, just slowly.
Slowly.
I think that's
okay. The function work is an asynchronous function that gets called repeatedly within GNU Radio. That function can be called at any time, and you have no idea when it's going to be called. It's called whenever work cycles are available by the CPU to be allocated to the module. So it's asynchronous, threaded to your code.
Line 301.
It's going to be called.
301.
It's
line 301.
Yes.
Right here.
Yes.
Okay.
That's the top of that block.
Yeah, the work function. You have no idea when that function is going to be called. It can be called at any time that GNU Radio runtime scheduler thinks that it needs to be called. And so you have no idea in your code that this other thread was suddenly given processor cycles to execute. The work function will execute asynchronously to your Python code and then exit. So it's not your Python code calling into something. The work function is a separate thread of execution.
Yeah. And so it's probably just reporting that it's, you know, that it's setting that lag, or that waiting flag.
And because of the nature of how Tom described the structure, it would come at irregular intervals or maybe regular intervals, and that would cause you confusion on how it works.
Right. So it's usually a little dangerous to have prints inside of asynchronous threads because strange things can happen. But this will be called, and if it prints out things, it'll print them out totally unrelated to the Python code.
So
Okay.
maybe you ought to contact Yuha and ask him what's going on there.
Okay. Okay.
Yeah.
Okay.
I mean, he wrote the code, right?
We think so. Yeah.
Yeah, no, he definitely did. Do you have a recommended way of going through and debugging this if we can't put print statements in?
Yeah, I use print statements knowing that they may corrupt things. And so sometimes they're helpful to figure out what's going on. But at other times they can mess you up. And so you have to be very careful when and how you do it. And usually before you move on, it's a good idea to comment them out.
Yeah, is there a particular GNU Radio tutorial that does a good job of, you know, showing how these work functions and how the C++ and Python interface work together?
Yeah, the tutorial on how to write an out-of-tree module in C++ discusses the work function and the scheduler. It goes through a lot of that. The learning curve is somewhat steep.
Okay. Dev, maybe you want to take a look at that one.
The learning curve is not steep or very steep?
Is very steep.
Okay, that's good news.
Yeah, right.
It's a challenge.
Right. So remember what the work function does. It's intended to, basically the way GNU Radio works is there's a scheduler. And the scheduler tries to pull samples out of your module. And it does that by calling your module's work function and essentially asking, do you have any output samples for me? And the work function hands any output samples to the scheduler. The scheduler then, after your module pulls samples, the scheduler will go to things feeding your module and ask them if they have any samples to send to your module, and it'll work its way from the output back to the input. So the scheduler is basically going around calling the work functions of all the modules to shuffle samples between the modules. Does that make sense?
I apologize. I did not completely, like, the voice was not clear enough for me to be able to comprehend that last sentence.
Okay, the key thing is that the work module is on a thread. It can be called anytime. And so your work module has to be what's called thread safe. Otherwise, weird things can happen.
Okay. Okay. So this is this chop down convert code. Like, I added this one line. The print one was already there, the first line. I added this. I added here and somewhere. I have added 3. Print. I added these just for the sake of confirming that if I put print commands here, like, it will come out in the where it was coming out from.
And that's
so
that's fine as long as you take them back out again.
Right, right. So you have to remember one of the classic undergraduate CS courses they teach you about threading by giving you a module with a print statement, and you call it and it's halfway through the print statement and it gets interrupted by another call to that same module. And so halfway through the print, you call the print again. And so what you end up with is a totally garbled print whose values look kind of weird, because in fact, print got called while print was in the middle of being called from the previous one. So it's the whole issue of thread safety, which is where you basically want a threaded module not to have side effects and to get out of itself as quickly as possible. So you can put prints in, realizing that you can't always trust what the print prints.
Yeah. Sometimes a
Okay.
put S might be a little, it's at least a smaller function that happens quicker.
Yeah, if it's
Okay.
if it's real quick, a lot of the time things will be okay. You'll occasionally garf stuff up.
Yeah.
So I was trying to understand, like this from, for example, this is a set time double T, double D, okay, T, and what are these? Like U integer 64 underscore T, what are these?
Specifying
Okay. It's doing a type conversion. So it's taking the variable SR, it's converting it to an unsigned 64-bit integer type pointer. So it's a pointer, it's treating it as a pointer to, let me see, where are the parentheses here? So it's casting SR to an unsigned 64-bit integer type, and then it's treating that as a pointer, and T is a pointer to an unsigned 64-bit integer type.
Okay.
Yeah, it's just
So
being absolutely sure how much memory that variable's taking up.
Or I'm sorry, that's not a pointer, that's a multiply.
Yeah,
One of the problems with C++ pointers and multiplies look the same. So it's casting SR to a 64-bit unsigned, and then it's multiplying it by T. It's taking that whole thing, casting it as an unsigned 64-bit type, and then assigning it to start T underscore U64.
Yes.
That seems a
My
little
apologies,
paranoid.
my apologies.
Yeah. You
So-
don't want to take
so
chances
given-
on that.
So given this complexity, like, so I'm trying to change the source here, which I have done here. I'm changing the source here. So, and I'm trying to have the source as digital RF. And the digital RF data is also created by the GNU radio. From the, like, as I looked on the waterfall plots, I recorded them. So in this initial code, I think before I leave, I should ask the first question I was trying to ask. So where should I start? Like, to understand the message, why the message is coming out. That's where I am right now.
Okay, the message is in the work thread of an asynchronous module. Nothing you're doing in Python is a call to print that. Nothing you're doing in Python causes the print to happen. The print is in C++, I think. It's hard to tell with all the code flying by on the screen. But the print is in an asynchronous thread being called by the GNU Radio scheduler.
So I am mistaken to believe that that message comes out at this line.
You can't, no, that's not, from what I think I saw in the code, it's not related to a line. It's not a flow of control from your Python code. It's asynchronous to your Python code.
That's interesting. That's interesting. Okay.
I think one of the places where we're struggling right now is, what I said to Dev was, okay, we're having a hard time being sure that we can synchronize to these ionosons as they're coming in. So I said, well, why don't we try recording the raw samples to disk using digital RF and then play them back into UHA's code from digital RF. So essentially replace the GNU radio block with the digital RF radio block reading from the file. So yeah, I guess we're struggling with that. It's not as simple just drop in and replace the block. We're having a hard time understanding how the flow of data goes from one place to another.
Yeah, yeah. The data flows through the flow graph under control of the scheduler. And what your Python code does is it sets up all the blocks. It defines the parameters to the blocks. It wires the blocks together, and then basically tells the scheduler start flowing data. That's the general way that GNU Radio works. So you don't have a direct relationship between the flow of samples and the Python that you see in your setup code.
Mm-hmm. So we can never really see the samples in the Python at all.
You can see the samples in the Python, but in general, you don't want to be processing samples. Python is very slow,
right?
And so that's why out-of-tree modules are written in C++, because it's much faster. When you're trying to handle raw samples in Python, it generally, the flow graph can't keep up. The easiest way in general is to use GNU Radio Companion to let it compile your flow graph into Python code, and then use GNU Radio Companion to break open flows and to attach instruments such as spectrum analyzers, oscilloscopes, and things. That's the easiest way. Now, it's possible to write a flow graph in Python without using GNU Radio Companion, but then you have to yourself attach the monitoring blocks in your Python code. Some people can do that easily. Some people like me prefer to use GNU Radio Companion to make that graphical rather than by text.
Right. So and we've done some of that, and you know, Dev has shown you his flow graphs before in GNU Radio Companion, but now we have UHA's code.
Okay.
And so I don't think there's a way we can go backwards, you know, taking UHA's code and putting it into GNU Radio Companion.
Yeah, yeah. If you craft your own Python code, it's pretty much write-only code.
Yeah. So I guess what we were trying to do is, obviously we're going down a rabbit hole here trying to understand what's going on, but I think it is worthwhile trying to understand what's going on.
Yeah. Debugging at the Python level is easier than trying to understand what's going on at the C++ level, because in Python you have a sequence of instructions that you can see, things that you can print between instructions, and that's very difficult to do when you're in the scheduler thread of the code, because stuff is happening that you really don't know about.
Yeah.
And so unfortunately, that means you have to understand Python, and you have to understand how GNU Radio sets up and passes information and wires up modules in Python. And the easiest way is usually to take a flow graph, let GNU Radio Companion compile it into the top block.py module, then go look at that module and see how it's written and how GNU Radio Companion wrote it.
Right. Yeah, we've done that part. So
okay.
Yeah, we've looked at that sort of thing. But yeah, now trying to go into UHA's C++ code, and I think that's where we're hitting a wall.
Okay.
Because
yeah, that's why the learning curve is kind of steep on this.
Yeah, I think Dev has the first start where I think he's been able to replace the USRP GNU radio block in the Python code with the digital RF radio block. I think that's okay. But then I don't think he has connected up from that properly. I'm not convinced that the data is actually flowing from the files the way we hope it is through UHA's program. I'm not convinced that. I know we haven't done anything in terms of reading the timestamps off of the digital RF files. So where somehow UHA's code uses the EDIS, keeps track of both EDIS time and CPU time. Since we're reading the digital RF files, we don't have that. We haven't connected the timestamps that have been recorded through the system yet. So there's like a lot of things that are not connected properly or lined up yet. And Dev has gotten to this point where he found, okay, I know where there's this one loop that UHA's code is working on, and it gets there with the EDIS, but it doesn't get there with the digital RF. And so that's where he's trying to figure out, yeah, I think like what is that waiting flag? What's triggering that waiting flag? And why is it not going over?
Yeah, in the Python code, you define all the modules, and then there's a bunch of Python instructions. I think they're something .connect, and the connect statements are how you wire the ports, output ports of modules to the input ports of other modules.
Mm-hmm.
Now, Michelle mentioned that there's a group of a GNU Radio listserv where you can ask questions.
Yeah, I sent that. Well, I sent the chat over to Dev. The chat.gnuradio.com. I have. Yeah, there's also listserv you can ask.
Have you actually talked to Juha about this?
I think we need to talk to him again. We've talked to him once a long time ago. I think
Don't hesitate
but,
to talk to him. He's very accessible.
Yeah. So yeah, I think
But
Dev, I think you should contact Juha again.
Yeah, but when we talked to him, like we had very like inchoate ideas, like not fully developed ideas, and we did not have any developed questions as well. So we were not as much deep into this as we are now. So we were just curious. So we were just curious back then, but now we are under trouble. Okay.
So didn't Juha work at Haystack for a while?
Yes, he did.
So he should be familiar with the database
and digital RF. He should know this stuff, and it's very possible this is something that he'd want to be able to do anyway.
For all we know, he wrote it.
He wrote it.
I mean, he was very much involved.
Well, maybe he's already done it.
Right.
Yeah, Deb, I think you need to keep emailing Juha, and maybe we need to set up a Zoom call with him again.
And if he hasn't done it, he would probably be willing to help.
Absolutely.
Yeah, one of the issues with the USRP modules, it's difficult many times if you have very time-critical buffer and time-stamping operations to do it what you want to do within GNU Radio Companion, and it's much easier to do in the Python top block, and likely that's what Juha was trying to do when he wrote it the way it is. And unfortunately, that makes understanding and modifications quite difficult.
Okay. Thank you so much.
The only problem now is that he's 6 hours ahead of us, but other than that, I'm sure he'd be very interested in helping.
Well, you can start by email.
That's true.
And it's good now because we are like, we're getting deep into his code, whereas like before we weren't. But now, Dev, you've really spent a good amount of time like diving into his code, so you have a much. I think you can have a good conversation.
Okay. Okay. Thank you so much.
We're kind of getting past our time.
Yes, we are.
So I'm going to go QRT. Enjoyed it, and we will be in touch. And Dan, I'll send you something probably by the end of the week. Some script information. Thank you.
Yeah, good luck everyone regarding fires and hurricanes and all that
Yes.
fun
Yes.
stuff.
Hey, Scotty,
Yes.
before you go,
Everybody's battening down the hatches.
Yeah, hunker down.
73.
We're in
73.
73,
Trenton.
Bill.
We actually had a lightning induced fire here.
73. Thank you so much.
There's always something.
hey, Scotty, are
See
you
you,
there?
Dev.
Scotty,
Good night.
James wants to talk.
Oh, sorry, have to unmute. I'm here.
One quick question and one that was addressed earlier tonight. You mentioned, I think, over the weekend in DCC that there was a question about cases for the Tangerine. Have you identified a case that might work?
No, not yet.
No. Okay.
Someone
and the
asked why we put IOs on two sides,
right,
which would make it harder to put in a case.
but you haven't selected one yet.
No, in fact, it'll probably be some kind of custom case, or maybe we can take it off the shelf one and modify it. And maybe we'll get somebody that's handy with a 3D printer to print us one.
Okay. The other question, it was actually slightly addressed earlier tonight about availability. The dates that you specified over DCC, which was late this year, early next year, is that for prototype status, or are you thinking of doing a production run?
As for prototype status, the production run will follow that.
Okay.
As soon as we get, and I'm thinking that as soon as we get the board built up, the 25 boards built up, and it doing something useful other than blinking an LED, like gathering enough data that Tom can prove out the receiver board and making sure that we don't have any errors on the board, then that's at that time. If we don't have any, then I don't see why we can't go to production. But that's a whole nother bucket of money, and I'm going to go back to ARDC and ask them. Tapper will go back and ask for production money, because in order to get the price down, we got to build these in groups of like 250 or 500, and that costs more money than we have. So we are going to have to try to get some support from them to do this. And they seem to be amenable, but we'll see what they say.
Okay. So enthusiasts probably aren't going to see anything until what, late 21, early 22?
No, I think it may be faster than that. It just depends on how fast we can prove this out, because I'm intending to write a FPGA program for the data engine to test the hardware, a manufacturing test. So if I've screwed anything up, it's going to be obvious in that manufacturing test, and we should find it. So we can either fix it, spin it, or we can spin it again. I think, Nathaniel, we have in the budget, we have another spin scheduled, but we really want to hold off as long as we can before we do that, but so we get all the features and fixes and everything in. Now, if we deem that everything's great and we're good, then we could go ahead and go into production with this board. Because one of the things I really want to do is I want to come out with a higher end board, because I think that we're going to run out of gas here. The personal space weather station is going to be fine, but if you want to do, but we have a lot of high performance RF coming into this board. And we could use a lot more compute power in the data engine. So the next version may be a Cyclone 5 version rather than a Max 10 version, which will make it a lot more expensive, but it probably double the cost of the data engine. But the result will be of something between 6 and 8x the compute power.
Oh.
So it's really going to be worth it for the people that need it. And then if you don't need it, then you don't use that board. But so it's yet to be determined what Mark II will be.
Yeah, I've got a question of schedule regarding the clock board and the dual frequency GPS. Any idea of when we would be getting that running?
Well, I took a swag at it and said February of 21.
Okay.
But that we'll see, because John's working on that. And I think it's going to be, I'm going to be helping him with the logistical details once the data engine gets done. He's going to be the architect, but I think I'm going to try to help him. Right. So we'll try to speed up the logistics of getting the thing into CAD and getting the board laid out so we can get a prototype fast.
Yeah, I asked specifically because we're running correlations between TIDs and TEC measurements. And it'd be nice to have them both in available from our.
Well, one of the
individual
things that
receivers.
John wants to do is he wants to build a carrier card that will take the clock module and turn it into like a lab grade instrument for your shack.
Right.
So you could just buy a clock. You say you're not interested in the data engine or the SDR or anything, but you just
Yep.
want a
But
high grade clock standard.
yeah.
Mhm.
But
Yeah.
we're
So
interested
is the
in
idea
both.
like, so it'd be like instead of Leo Bodner GPS
Right.
deal, it'd be like
So
a
this
John
would be far
Ackerman.
beyond.
The John
Far
Ackerman
beyond it.
GPS.
Yeah.
Yeah.
But
that'd
this
be the
would be a much higher performance than
time
Bodnar.
lapse GPS.
Yeah, because Bodner's is not a dual frequency GPS, right?
Not dual frequency, and it's only a TCXO.
Okay.
So it's not very good at holdover or anything like that.
Well, what John and I were even talking about an oven controlled oscillator version, and we put provisions in there to power that.
Right.
At a future date. So we may have multiple versions. So we'll keep John busy.
Yep. But as I say, we're actually doing with our receivers, we don't have the dual GPS at our receivers. We're doing the TID measurements on, AM broadcast stations, but, we're using other people's TIC measurements, the GPS dual
Well,
frequency
the other
stuff. So
interesting thing is that this board's
nice
going
to have them together.
This board's going to have an FPGA on it, a small one. So you may be able to do some interesting things that were never really intended for it to do in the future,
Right.
Once the board comes out. So it's just that there's some things that John wants to do that seem to lend itself to an FPGA, and it won't really be very complicated. It's mostly a distribution hub, if you will, but there's a few correction things he wants to do with some counters and comparators, and it's only a few bucks for the FPGA, and it will become pretty easy to do when you put one of those on there. So
Yeah, but also it's good that John's designing this to be able to run standalone, because there'll be a good market for that alone.
yeah, won't quite be standalone, but it'll be able to be plugged onto a carrier board with minimal support. So
Right.
the carrier board will be really cheap.
Yeah, but you don't need the whole RF section.
Right, right.
So what are the chances of seeing a working prototype at Dayton next year, assuming it happens?
Well, I was supposed to have a working prototype of the data engine last Hambench, so they're going to be after me with pitchforks and torches if I don't have something by next generation. So yeah, so I think the chances are very good of having at least all the hardware prototyped. Whether we have actually, I mean, because the firmware and the software is going to be an ongoing thing, and I'm not sure I can predict how it's going to go, because we've targeted lots of different target markets for this. So it's really going to depend on who's the loudest, jump up and down. I want this, I need this. And I mean, personal space weather station is kind of first in line. But after that, who is going to want what? And I mean, there's only a limited number of developers, right, Dave?
Yes. So you got to be careful. Scotty's a hardware guy. It's all done once he builds the hardware.
That's right.
But there's no software in it.
Software is not my problem. Well, he had a professor at ASU, and his trademark, he was a hardware guy too, he's my hero. His trademark was load A, store A, how hard can that be? That was his comment on software.
If it's really hardware, it's just going to work. You don't need software.
Yeah, and software's
real
free,
hardware.
right?
No, all you software guys have to fix all my mistakes. Okay.
Right.
Right.
I need to go, so I'm going to say 73.
SRR, software repaired radio.
I can see, Nathaniel, you're still not recovered from the weekend, and neither am I. So.
Oh my gosh, I think I'm in the permanent state of non-recovery right now.
Yeah, well, so see, I had to, but because I was getting irrigation Friday night, right? I had to finish mowing the lawn, because you got to cut it down so you don't have to water something really high.
Okay.
So then right after DCC on Friday, I had to go out and mow the grass, of which it was a continuation of Thursday's mow the grass. And then in the middle of the night, there was irrigation. And in between the irrigation and the mowing, there was these things called DCC that you had to run.
Yeah.
So yeah, it was like by Sunday, I was going like, I don't believe I even made it through all that. And I'm still not recovered. I just like, Mostly today was paperwork, getting all of the POs in place, and I sent you that.
Yeah, and now what I have to do is I have to go through and do a rebudget and stuff like that. So the first thing I have to do is I have to design a take-home DSP exam for poor Jonathan over here, and and I have to, I'm hoping to grade. They had some sort of computer programming assignment. I'm hoping I can grade that tonight and get that
So
back.
how did your watch the DCC presentations and write up a report on it go? Have you gotten a lot back or any feedback yet, or is it too early?
I think I made it do this Friday. I've gotten a couple back already. I also made the assignment such that you got credit for it if you either did a write-up about it or if you presented at the workshop. So for people who presented, they got full credit just by giving their presentation. Yeah, I felt that was fair. I felt like people presenting put a lot more hours into it than just people watching. So
Yeah, I like the people say, well, presenting, that's only like 20 minutes. Wow, that can't be too hard.
Yeah, that was that
courses,
comment.
right?
That comment that like, oh, all of the time that you saved now that you don't have to do logistics for the in-person one, you should now have this conference like 4 times a year.
Yeah, oh yeah, I love that. Yeah, we could do that 4 times a year. Good.
Yeah, that was like yeah. So it looks like
Yeah.
I got 5 submissions for the people watching the DCC so far.
Okay, good. Well, I think that the best thing we could do is keep it to once a year and pair up with HAMSci so that you
like
got
that.
2 a year, and then you got a
Yes.
scientific focus on one and an engineering focus on the other, and it's good. They feed off each other.
I like that a
works.
lot. And it kind of spreads out the responsibilities a little bit, and they each have a little bit different flavor, but yeah.
And if you know you're really bored and you have nothing to do, then you should get your butt on here and sign up and start programming and doing some R&D on the hardware.
Exactly. That's
Working
right.
on
That's what I told people. I'm like, we actually meet like 3 times a week.
really.
Every week. So I mean, if you want this, you can show up.
You can burn yourself out on meetings if you want.
Oh, I know. I like my schedule is just it's just crazy.
Yeah, and frankly, the HAMSci bi-weekly meetings are pretty much seminars.
Yeah.
Yeah, when Dave gives his talk, those are great. Except I'm gonna buy him a new mic and send it to him because that mic he's got is awful.
Oh
I
yeah.
think he's actually got a new one that he should have by now because it was coming. He's getting a new headset.
Dave McGaw, I don't think you've been to that one because on Thursday mornings at 10 a.m. there's a telecon that Case Western hosts. That happens every week. Yeah, and what Scotty is referring to is David Kasdan. He's been giving these lectures on basically signal theory and Fourier transforms, and they've been really good lectures.
Oh,
yeah, really good to refresh us guys that went to school 40 years ago and don't remember all those classes.
It's hard to find a link for that.
No,
it's actually gave me one once.
It's now posted on if you go to hamsci.org and you go to the Get Involved tab, it's now on the calendar there.
Oh, all right.
Oh, good.
So
are the recordings somewhere, Nathaniel?
They are, but they're not in the same place as everything else. Christina maintains some sort of a list. So you can email Christina for that list. But yeah, if you go to hamsci.org and click Get Involved, there's a calendar, and it is there, and the link is there, so you can just feel free to show up.
Oh, very good.
Yeah, so the Thursday morning ones are really good.
They're very good, yeah. Yeah, the Thursday morning ones.
Even though I have to get up really early.
10. Okay. 10 to 12. That's a long one. Does he actually use the 2 hours?
I'm a nighttime person. I don't like these.
Yeah, it's supposed to be only like an hour, but everyone always it usually takes about 2 hours.
Like this one.
And that one's been a really good meeting too, because the Case Western group, they're doing the low cost personal space weather station. I think they're really laying a lot of the foundation of what kind of measurements we're actually going to be making with this thing. They are actually doing a lot of the real prototype of like how do we actually collect data and do something with it, because they actually have about 9 nodes, 9 generation 1 prototype nodes that are currently running, and they've been doing a couple of campaigns where they've actually had people, basically the FMT type of people, make measurements of WWV for the festival frequency measurements. So Christina's actually been collecting that data, and she has a manuscript draft that she's working on with that data. So
Don't
so
they
they're
have like
actually
more than 2 years worth of data now?
yeah, I think probably
A lot.
Now,
yeah.
notice these are all saying that they're about WWV Doppler measurements. Is there somewhere they say what the topic actually is?
It just changes every week.
Okay.
It's kind of like this. It's whatever needs to be talked about. Christina will sometimes send out an email saying, here's what our proposed agenda is. Last couple weeks, one of the things we've been talking about is we're trying to get the magnetometer boards that we're doing for Tangerine SDR. We're also trying to make them compatible with a low-cost system. So with the low-cost system, there's gonna be Raspberry Pi, and then John Gibbons, N8OBJ, has designed a Raspberry Pi hat that has a WWV receiver on it, and then we're going to the idea is the magnetometer hat. It'll go Raspberry Pi, magnetometer hat, and then the grape hat. So it'll be a little sandwich.
Like a 3-board stack.
Yeah, 3-board stack. And I don't know if we can. This is one idea that came up with over the Capra DCC was, right now they're relying on, I think, basically Leo Bodner GPSDO for their frequency stability. And, we asked the question to John Ackerman, can we get the price down if he can design a board that has an onboard GPSDO, even if it's single channel?
Mm-hmm.
And didn't he come back and say that there was a U-Blocks version of the dual channel module that was a single channel module, so he might be able to put it on the same board?
Yeah. So
Yeah,
if we could talk to, and John Ackerman may not have to do all the design work, because that might be something that John Gibbons, who's doing the design work for the grape, he might be able to put that in there.
Well, I think John's module is standard with a single frequency, but you can add substitute the dual frequency module.
I think as I remember,
it's a higher end.
He was asking if the dual frequency module had the same or John Ackerman's answer was that they didn't have the same footprint, but often you can design a board that has 2 footprints,
right?
And just solder the one you want to use.
So we'll keep that in mind if we don't.
Yeah,
if
same way.
Or too big.
Yeah.
Same way we do with different oscillators. You can put a TCXO or an OCXO on there. You have multiple footprints, so people can substitute what they want.
And one of the things that, Nathan, you might remember this way back at the beginning when we started doing this on TeamSpeak. Remember when Rick Hambley used to show up and talk to us?
CW2GPS.
Yeah.
Yeah.
Well, he told us at that time we were looking at the LEA M8F, I think, or M8T. Anyway, with the previous generation of U-Blocks ones. Well, he said he uses that in a product, and he might be able to get us a special deal on the price because he buys a lot of them. So, and now what, 1.5 years has gone by. I don't know what he currently uses. I haven't talked to him recently, but his business is selling timing products. So if we pick one that he uses, then we might still be able to get that deal if he's willing to do it for us.
You know his background? This is Rick Hambley. Oh, he's the one at shoot, what's the company he's at?
Yeah, I don't know. I don't remember the name.
He
of
does. He's the one who does TAC 32.
Yeah.
The
Yeah.
software.
Well, he sells hardware too that gives
Right.
an order of magnitude better performance for the same amount of money than anything else on the market, as far as time measurements.
Yeah, I'm trying to remember the company's was.
Yeah.
But it's a timing company.
I can find this. He's in Maryland.
But if there is a way that we could basically get that GPSDO integrated into the low-cost system at a price that's less than people supplying their own
I mean,
Leobodner.
the single frequency one.
Yeah.
Well, because the grape doesn't need the dual band one, right?
Right.
Yeah. It's CNS Systems.
Right. Yeah, they make GPS receivers and such.
Yeah, he knows what he's doing too. So he's been doing this a long time.
Right. Now, periodically we get an update through Tapper on the TAC 32 software.
Yeah,
I don't think it's been updated in a while.
The hit I got here was from, looks like DCC 2007. He was given a presentation.
Mm-hmm.
But a long time ago.
Hmm.
Okay, well, cool.
That sounds really good. I feel like there was one other thing I wanted to say, but maybe that will just wait for some
Have you
other
do with
day.
the magnetometer?
Yeah, I don't know. The magnetometer thing, that's like a paperwork issue for me right now, which I have to work on. I'm glad that you're talking with Jonathan about the VLF receiver. I'm hoping to see that get developed more. And
well, I'm going to be talking to Jonathan a little bit later because we got to work on the pin out of that connector.
Yeah,
and get him what he needs.
And we are, let's see. So, have you heard of Eclipse Mob?
Eclipse Mob?
Yes. David, you know Eclipse Mob?
I might have. Did you mention that in your presentations in the past few years at?
Yeah, it's been mentioned a number of times. It's another citizen science radio project, but it's focused more on VLF instead of HF, and they've been looking at VLF signatures and propagation during eclipses.
Well, Jonathan's receiver will be perfect for that then.
Exactly.
Right.
So I'm having a Zoom. So Bill Lyles is very much he knows the Eclipse Mob team very well, and he's been working with them for a number of years and has done like design work for them and stuff like that. And so now I'm going to be meeting with the PI of the Eclipse Mob project this Friday morning, and we're going to talk about ways that we might be able to help each other out and collaborate. So like if we're able to, so this is a way that like, yeah, Jonathan's VLF module might be a shoe-in, and it might help, help out the Eclipse. If we're able to basically be an Eclipse Mob receiver and get our TangerineS out there as well,
Well, and I think it's early enough that if there's a feature that they need, Jonathan can put it in because he's working on it right now. So kind of like where we were a year ago, going around asking people, what do you want? What do you want? What do you want? And making sure we put it in.
Yeah. So I'm probably going to meet with her just by myself first. And then we'll see where that goes. And we'll probably like rope Jonathan and Bill Lyles into the conversation as well. And then we'll see if we can just get all the specifications, the requirements written down and see what we can do with this.
Okay.
Well, Scotty, I was worried about the clock issue because that's kind of integral to my whole project, and I want to make sure that we could figure out a way to get these clocks synchronized, because I had thought that the way that I was going to do this was the same way that you were going to clock data in from the RF modules. But I remember you said that those clocks, so the clock driving the RF module is somehow synchronized with the FPGA.
Well, on the receiver, the clock module or the clock chip drives the receiver module directly, and then the A to D converters have a source synchronous interface on them, so they generate the data out and the clock synchronous with each other, and that's all sent to the FPGA. So each data stream coming from an A to D converter has its own clock coming from the going into the FPGA.
Oh, that's how it's done. Okay.
Right. So that's how we can just run at such a high speed.
So do you think that it would be possible to get, so the A to D converter that I picked from Cirrus Logic can generate these clocks. It generates the serial clock from the master clock. So can we do the same thing?
Yes, I think so. In fact, that's probably the next thing I have to do is revisit the clock scheme now that we know what you need. But the problem I'm having is you're going to require a GPS to operate your VLF radio.
Yeah.
But you're not going to require a GPS DO dual channel GPS to do it. So I don't want to put the requirement on the system that you have to buy this $300 GPS unit for the low cost medium or low frequency receiver. So perhaps we either need a lower cost GPS DO, like something, at DCC there are people saying, well, here's a link to a $3 GPS. You can use that for your timing. Well, no, you can't, because it's not a timing GPS. But maybe that's sufficient for the VLF receiver. I mean, you're not going to get 10 nanosecond or 50 nanosecond accuracy, but maybe all you need is 500 nanoseconds.
Well, it depends on what you want to do. If you're looking for things like whistlers and chorus,
Yeah.
you really don't. Well, VLFRX tools, if you're just looking for whistlers and chorus, you don't even have to timestamp with the GPS. So how it works is that it generates timestamps referenced to the computer's clock, and that must be disciplined with NTPD.
So no, wait.
That's down at the millisecond level.
But so Scotty, I kind of zoned out for a minute. So right now, the way the VLF board is being designed, we would not be able to take advantage of the high performance clock module.
No, we would be able to, but I don't want to make it a requirement if it's not necessary.
You don't need that precision is the point. And the fact is, any GPS that has a pulse per second output is going to be good to a microsecond, which is probably adequate for VLF.
Because the thing you need the high performance for is for like aggregate beam steering and things like that, right?
Right. But even a single channel is going to be good enough for a large number of our applications.
It's just
when we really get into the nitty gritty, you want
the base data engine does not have any GPS. It's on the clock module. If you want a GPS, you're gonna have to put a clock module in. You don't have to put a $300 one on there. Maybe we have a $50 one that just has a cheap GPS and a pulse per second, and that's all it gives you, and that's sufficient for the VLF.
Right.
So, so Jonathan, what we really just need to know what's sufficient. How much time accuracy do you need out of the GPS DO for time stamping?
I want to get at least 50 nanoseconds because that's what Paul specifies with a sound card.
Well, 50 nanoseconds in reference to what? To UTC or to samples or?
Yeah.
Well, 50 nanoseconds to UTC is aggressive. So I mean, we're going to barely be able to do that.
Not really. That a single channel GPS will do that most of the time.
Yeah, I defer that to the experts because I
Well,
think Rick was telling me that that was not the case, but I don't know. That's not my
no, we
feed.
do that all the time. It's not that
50 nanosecond.
difficult.
Okay, but
Yeah.
how about a cheap GPS? Could you do it with a cheap GPS, like the under $10 variety? What can you get?
I'll bet there's Chinese ones we could find that, yes, they can.
I mean, I'm all for.
We can buy whole GPS DOs that are good for that for $70 now.
But I mean, the best scenario is you figure out what kind of accuracy you need, and then you design to that.
Yep.
The other alternative, and we do this all the time, is what's the best cost-effective method? How much money do we have? We got $10. We buy the best one we can for $10. And it either works or it doesn't work. And if it doesn't work, well, then you got to rethink it and say maybe we need the higher performance clock. And I think this is where we get stuck because there really are two ways to do the design. And HPSDR just did this and said, we're going to pick the best, and we don't care how much it costs within reason. But we can't do that for
I think
this.
John is designing the clock card so that we have all these options.
Well, it's going to have to be more than, I'm hoping it's more than one clock card because this one is not going to be cheap, the one he's working on right now. And the question then becomes is, can we make do with a cheaper one in the VLF case? Because the VLF card is going to be a leaf board. It's going to be cheaper than the RF modules. So the goal here is kind of make this inexpensive as possible. Well, then you don't want to save a whole bunch of money on the RF board and then blow it all on a GPS that's way more money than you need, way more performance than you need. But
well, what's the low-cost space weather station using to lock with?
Yeah, that's a good question. Because they need a GPS too.
Well, that's what I was saying. Right now they're using the Bodner, but they would, we need to see if we can.
But is that sufficient? Is that more than sufficient?
Yeah, well, that's $200, and we should be able to do better than that.
We're going to be better than that.
Right.
I'm thinking. Well, we won't be under $200, but we'll do more than that, and we won't cost very much more.
Yeah. Well, we'll see. It may be that once John gets his card running, we may be able to develop a stripped down version of it.
Yeah. So the idea is that I want to be able to at least satisfy the rudimentary requirements of what Jonathan needs. Even if you take a serial port GPS and plug it into the Raspberry Pi, I mean, if we could make that work, that'd be your solution temporarily until we got a low cost clock module.
Well, my envision with this module is that it is high quality, and because it's high, and the design was originally thought of was to replace a high quality sound card, and that includes very accurate time stamping.
So how does a sound card get time stamping that accurately?
So
not a GPS.
So what I did was I posted the documentation in a link to that section in the documentation in the chat. So what it does, you plug in a pulse per second signal into one of the channels of the sound card.
So it does use a GPS.
Oh, right.
And
yeah, we were doing VLF work and doing exactly the same thing.
But that means you need a GPS to get the 1 pulse per second. So you do need a GPS.
Yeah, but any old GPS, like I say, is better than a microsecond. And that's more than sufficient for this work.
Well, if that's sufficient, then we have our solution because we can use a cheap GPS and make a cheap clock module, inexpensive clock module that is just good enough, and then compare it with the leaf board, and you got your system.
Well, the thing is, there are 4 major applications listed for accurate time stamping. One is for when you're combining outputs from 2 sound cards. So each stream needs to be timed better than 5 milliseconds in order to prevent audible artifacts. Arrival time triangulation. We need an accuracy of 100 microseconds or better. And coherent reception to achieve phase coherence between two sound cards. Now, since we're only going to be using one sound card, that really isn't going to be an issue because it's coming from the same hardware. Also, precision, frequency, and absolute phase measurements. For one example is monitoring sudden ionospheric disturbances. And he uses his program, VTSID, and it requires, what does it require? That, let's see. Here it is. So VTSID requires, actually, it doesn't say, but you can't really get good measurements with VTSID if you don't have a good timing GPS.
Yeah,
So,
Jonathan, you're sampling at 192 kilohertz, right?
yes.
That's 5 microseconds. You can't get better than that. You don't need better than that. So a microsecond pulse per second is, you know, even with an interpolation, that's
if you feed
pretty.
the 1 PPS into one
That's
channel
adequate.
of your 192 kilohertz sound card, then you're only
Correct.
going to get one sample every 5 microseconds anyway, right?
That's right.
Right.
Well, that
So
should
that's
be
the
doable with
accuracy
a
you're
$3
going to get.
one. You should be able to use a cheapy one then, right?
Yeah, any off the shelf. We've been doing that. We did that actually like a decade
So
ago.
let me just ask this logistically then. If we were to say, get a relatively inexpensive sound card that was either USB or serial port and plug it into the Pi, is there a way that we can interface that to the software that you're talking about, Jonathan? Because
Yes.
we're not using a sound card anymore, right? We're using an A to D. So now we have to find a way to synchronize that, and it's sampling. Well, it's still sampling at 192K or maybe 384.
Yeah. Well, what Jonathan's saying is you're running a multi-channel ADC, and one channel has your pulse per second on it. So all those channels are synchronized, sample synchronous.
Correct. But when is the synchronized pulse? Well, that's easy enough. You feed that into a register that gets clocked at the same time as the ADC.
No, you don't have to do that. You're just reading it out of the audio record, the wave file.
Yeah, yeah. He uses FFT to find the occurrence of the pulse per second in the 3 different ways.
But so how are you physically going to get the pulse per second into the system?
It's just an input to the data, the sample stream, and then you pull that out in the data analysis later. You don't have to synchronize the processor to it.
Well, so how you just read it as a GPIO?
No, you read it as part of the wave file.
Okay.
So
then I need to capture it synchronously with the samples that I'm capturing.
No, you don't capture it. It's just part of the data stream coming off the ADC.
Well, okay, how? The ADC is giving me, say, 14-bit samples, and I'm getting a stream of them. How do I know which one's aligned with the 1 pulse per second?
You don't have to.
Okay.
You're just taking the data.
Okay.
You just take the data accurately. Don't drop any samples. Just stream it.
Okay.
And it's like 4 channels coming in, 3 are actual VLF data, and 1 is your pulse per second. And they are just being taken synchronously, stored in one file. And
Okay,
then
well, so
the
so
data analysis goes back and finds the transition and says, oh, that's the beginning of our second.
but that means that I have to have a 1-bit sample input that samples the 1 PPS synchronously with the 3
No.
channels. That have,
No, you don't need to know anything about it.
we,
Well, see, with this board, my envision is that we don't have to do that because the FPGA is already applying the timestamp.
Okay,
And
that's fine.
and
I'll
with
let him. He'll come.
computer sound card,
Love you. It's been a long
that's
meeting.
what we need. Or with the computer sound card, you need to capture the pulse per second signal. But with what you're doing, we don't need to do that.
well,
That was the whole point.
it's all great and good to say that you don't need to do that, but somebody's got to do it. And if the PPS comes into my hardware, I have to do it some way. Otherwise, you aren't going to see any 1 pulse per second ever, because it's got to be captured somehow. Okay,
It's either going to be, let's just put it this way. It's either going to go through John's card or a similar card, or it's going to go in through a channel of the A to D. If it goes through a channel in the A to D, the data just needs some global timestamp to say essentially what second it is. When did you start taking the data? If it's John's card, then you already have the hardware there. You don't have to do anything different.
Well, you only have the hardware there if you design it there, and I'm talking about how do we design it now. So you have the GPS input coming in, and somehow that's got to be arranged so that I can timestamp one of those. The 3 samples come in at the same time, synchronously clocked, and there's going to be a sample every a try sample every 5 milliseconds, right? If we're going at 192K.
Microseconds, yeah.
Microseconds. And what's going to happen, one of those out of every 192K should be flagged as the synchronization point of the 1 pulse per second. So you got to be able to say those 3 are where the 1 PPS went off.
Well, it's just part of the whole timestamp system.
Well,
I thought you already had a timestamping
I'm
system.
trying to get that into my head, how we're going to actually do the timestamp system. It just looks like a single bit input that comes in synchronously with the samples.
Yeah, but that's coming from John's card.
That is. But where does the DE interface? Set John's card.
Well, you need to have that on the RF card too. This is not unique to the VLF. We need that on the RF card.
But it's, well, yeah, we do. But on the RF card, I get a clock coming in and I can look at the 1 PPS and mark those samples as they come in. So I can do it the same way if I have the 1 PPS on my card.
That's how that I want you to do it.
Okay, so you don't want to have anything to do with that timestamping. We can take care of it. But
Right.
I have to get a 1 PPS somewhere, and so I'll get it from our clock module.
Yeah,
I was have anyway.
Yeah, I was. That's exactly what I was trying to do, was to use your clock module to time and just avoid the external GPS in the left channel.
See, here's a major difference between the RF modules and the VLF module. Is the RF modules, I get the parallel data stamped with a clock synchronized with it. On the LF module, I get a serial stream, and I don't know when the hell a sample took place. I get the data many, many, many clocks later because it's serialized. So I don't.
Yeah, but
really
that's a finite delay. That's a calibration.
Well, if that's okay, if we can measure the delay and account for it, that's fine.
Right.
Is it fixed delay though? I mean.
Yes. It better be.
It better be.
Get
otherwise, it ain't gonna work.
Right. No, it's absolutely determinate.
And actually, in reality, since that is transmitting 4 channels at I and Q data, it's going to have a clock that's at least 8x faster than the sample rate. So even if I skip a clock, I mean, my resolution is going to be a fraction of the sample rate clock, a fraction of the 5 microseconds. So it's, as long as it's consistent and doesn't jitter around.
Right. No, that's absolutely needed.
Well,
jitter is
that's
distortion.
almost why I'm saying I'd rather, I think I'd rather find a way. Oh, we'll figure out. I don't want to design it here on the session, but there's having a 1 PPS coming into the FPGA should handle the problem. But what happens when I don't have a GPS and the 1 PPS comes into the host? I don't have a 1 PPS signal. How do we? The poor man's radio doesn't have a clock module, doesn't have a GPS module there. Well, you got to have a GPS, so you buy a $5 one and you plug it into the Raspberry Pi.
Right.
Now, will that work? That's my question. Can you make it work by doing that? And if the answer is yes, then we got our low-cost one, and I don't have to worry about it.
Well,
but it might bear thinking about.
Actually, that won't work because how VT time adjusts the timestamps, it uses the system clock, the computer clock, and we're not using a PC and sound card, so that won't work.
Okay.
So there's not really any way that we can do that, other than if what we can do is we can you may be able to input a pulse per second signal into my VLF module and just pipe that directly to the Raspberry Pi.
Well, we could plug the GPS into a serial port on the data engine and get the 1 PPS. Now that gives me the NMEA senses. It doesn't give me the 1 PPS, I don't think. I have to have a way to get the physical 1 PPS in some way, because that's the reference.
I'm confused because if you're got the 122 megahertz clock, don't you have a way of connecting a GPS to that?
Not necessarily, because we have the low-cost version that has the 122 megahertz VCXO with no GPS. It's not meant to have a GPS attached. What you do is you plug on a clock module if you want a GPS, which is okay, but then you have to have a clock module in order to do the VLF receiver. And
Right.
I'm hoping to get away without that as a requirement.
Well, I think for this application, if we want GPS, it's just going to need a clock module. But maybe we can, as I say, once that's up and running, we may be able to develop a stripped down version of it.
Yeah,
It doesn't have all the bells and whistles.
Because all we really need is the 1 PPS and the sentence that tells me what the time is, right? The correction. And then the FPGA can calculate the 1 PPS to.
Yeah, and you don't even need the correction at this point. It's good to 100 nanoseconds without it.
Yeah, because you don't need real timestamp, right? You just need a relative timestamp.
Well, no, it has to be real. It has to be traceable back.
Okay, so you want to know what UTC time that 1 PPS comes in. Okay, so then I do have to have the sentences from the GPS, right? Because how do I know what real time it is?
Well,
that's easy because we have provision to do that, even with a cheap GPS.
Right.
One of the main things that I want to be able to do is, let's say that if Nathaniel runs a receiver and Paul Nicholson runs a receiver, we have two VLF streams, and to be able to correlate those. So if I want to verify that the Whistler footprint is within Nathaniel's location and Paul's location, those two streams have to be correlated, and so that's one of the purposes of the GPS.
They're correlating with the timestamp, right?
Yes.
So that means that is I think requires more than 5 microseconds of Well, I don't know, because you're both of you are sampling at 5 microsecond rate, right?
Yeah.
So correlation better than 5 microseconds doesn't really do you any good, even across multiple stations, if they're all sampling at the same slow rate.
Well, he somehow is able. I don't know exactly how, because I'm gonna have to ask him. But he is somehow able to achieve time stamping within 50 nanoseconds of UT. And
But he's time stamping packets that come in every 5 microseconds.
Yeah, you'd have to do it through interpolation. And that is possible to do.
I think that
I see. So I see what you're saying. So really, what you want is this packet came in at the timestamp plus so many nanoseconds, and it because his clock at the other station is going to be asynchronous from yours.
Right.
Mm-hmm.
So you got to timestamp it to within 50 nanoseconds. Yeah, I can see where you. Yeah. But again, it's going to just depend on how good the GPS you buy is. Right?
Well, most people who set these receivers up either use U-Blocks modules or Trimble modules. They usually use timing receivers.
Okay, so they'll use an LEAF 8T or something.
Yeah.
Yeah. Maybe
Yeah.
That's still $150, I think. 140 bucks.
Yeah, the Z9T, that's
The Z9T is even more, but the LEA series is cheaper, but it's still expensive.
yeah.
This
That's why that I.
What do you have, Dave?
This is a Z9T with pulse per second and the two outputs and the timing. Exactly what you're talking about. You know, it's in a packaged exactly this way from on the two SMAs, and it was about $200 or something. But that's the Z9T.
Yeah, and that'll be the one we use in the high performance module.
Correct.
But what we use in, I mean, the question is how little can we get away with and cheaply.
Right, but this is the far end of things.
Yeah,
you might be able to use an LEA 6T or something like that.
Is that a lot cheaper?
Oh, that's a lot older. I don't know. There's 6s, there's 8s, there's 9s. I don't know that. I don't think there are 7s, as I can recall. Maybe there were, but there's a variety, and they don't exactly go away immediately when you know they may still be available, and that's just from U-Blocks. Of course, there's other ones from like this is a cheaper what was it, Sky Track, but it is also a dual frequency one. But there are lots of companies out there.
We wouldn't need the dual frequency.
We don't need new dual frequency.
No, but there are lots and lots of companies, and many of them have a timing module. How good they are, I don't know.
So then basically what it comes down to is it looks like we're going to have some kind of GPS on the clock module to do this. So
yeah.
Whether it's an expensive
one,
the expensive one will obviously work, but the cheap one is something we have to focus on, because just plugging into a serial port's not going to work. We got to have it more tightly coupled than that. So
well, I envision this module for use as a high performance with high performance GPS timestamping as well. I did not envision a cheaper module, because then you could just use any old sound card. So this was specifically slated for the VLF Professional that has a multi-channel high performance capture system.
So you already
Now,
have the cheapy system. You want the performance system now.
right, right, and what I want is I want easy setup. So with the VLF module on the Tangerine, that plugs into your switch. It goes over the internet to an Amazon server instance running VLF RX tools, and I also run one too. So what I want to do eventually is get a network of these receivers running over the internet,
Kind of like
because
personal space weather station model, right?
yes, yes, because that's how that we're going to be able to do the real science. Is we need a worldwide supply of VLF receivers. Then we could actually map propagation and understand that better. So Paul Nicholson, who wrote VLF RX tools, has a network of VLF receivers. So volunteers set them up. He's a volunteer too. He sets them up. They're streamed to an IceCast instance on an Amazon server that he's running, and then anybody can listen to that IceCast server and get a 32K stream. It's also possible to get a 192K stream if you want, or 96 or whatever. Some people run 96K sampling based on their sound card. So I want to have multiple of these boards and receivers out there. This way that we have a worldwide network.
You should be able to sample at the highest rate, and the FPGA can decimate down to serve up multiple rates if you'd like to do that.
Well, he does that in software. There's a utility program. So he has, I think, over 30 programs in his tool set that can do any that there's tons of stuff.
We just basically provide 192K samples, and then he takes it from there and does all the decimation and downsampling, whatever he needs to do.
Yep.
Do we need to go any faster than 192K ever?
Yeah, you might want to. The thing, though, is that we want to have one of the high-quality audio codecs because they have much lower noise and better resolution than the RF.
Well, I think Jonathan's picked out that high-quality audio codec.
Exactly. Yeah.
Yeah.
So we definitely want that ADC over the RF ADC. But otherwise, it's feeds into the same system.
I mean, it doesn't really matter. It's just going to depend upon what clock you need to run.
Right.
Because Jonathan, you're going to get one clock from us, and you may be able to tell us what frequency you want, but it's only going to be one. So that's sufficient, right?
Right, and that's all I really need, because all I need is one master clock, and it's going to clock this ADD converter. Now, I haven't really figured out yet exactly how I'm going to have the user select 1 to 4 channels, different sampling rates, because if you have a lower bandwidth connection and you want to sample at 96K, I want to have that option. So ideally you'd sample at 192 kilohertz, but some people might not have the kind of bandwidth or storage, so they could sample at a lower rate.
Well, as long as you do powers of 2, it's easy to resample down lower to decimate. So you still hardware sample at 192K, you just decimate and filter down to a slower rate if that's what you wanted. And you could do that simultaneously. You could have simultaneous streams at different data rates, so the users could pick whatever stream they wanted.
Well, these ADCs you can set to different sample rates as well,
You can
all
do that
running
too.
off a common master clock.
But then if you do that, you've got to be able to tell the FPGA what sample rate you picked so it can...
Yeah, that does have to pass through.
So I'm thinking, Jonathan, that we would probably just give you your own dedicated I2C port over to the clock module,
Well,
and then you would talk to the FPGA over there, and we would establish some kind of protocol for how you ask for clock speed.
so then, so but your FPGA is also going to have to control this ADD converter too. So it's going to have to be on the same bus. So well, do you have an I2C bus available that's going to be connected to the GPSDO and your FPGA?
Have as many I2C buses as you want because I build them in FPGA.
Oh, right. Okay. Well, then.
Yeah, you're going to need I2C to the card for configuration.
So I'm thinking, since we already have an I2C from the FPGA to the clock module, that's redundant then. So you're going to talk to the FPGA, and then it's going to then tell it what you want, and then it's going to set the clock speed for you, and you'll get the clock that you asked for.
Yeah.
That's probably the best way to do it. Although we got plenty of pins on the connector, and we got plenty of pins on the FPGA. Well, actually, we have more pins on the clock module FPGA spares than we have on the main FPGA. So anyway, so I get an idea what we need. So let me gem this pin out, and then we'll get together and talk about whether it meets all your requirements or not. Mm-hmm. And so we'll have to, I'm going to depend upon you to understand how your board is going to work, and that I gave you all the resources that you needed to do that.
The main things that I'm going to need is I'm going to need power. I'm going to need a clock signal. I'm also going to need I2C, and I would imagine that I just tap on the existing bus. And then there's going to be the I2S or TDM bus from the ADD converter. And so far, that's pretty much everything. Unless you want to have like a serial EEPROM for board ID. I don't know if you want to do that, because I know that you have one on the magnetometer board.
I think what we'll do is you should connect that up to the Raspberry Pi header in the standard method, so that it looks like a Raspberry Pi hat. And then if we read it or not, it doesn't matter. We don't even have to put it on the board if you don't want to, but we'll put it in the design so that we can be an official Raspberry Pi hat. And then, what we put in the ROM, we can figure out whether we want to bother with that or not. Because we're going to put one on the magnetometer, but I really haven't even investigated what goes in that part yet. It seems to me that we have to have some unique UUID somehow. Right. And in fact, my company, we built Wi-Fi cards, OEM Wi-Fi cards, and we actually bought a block of 16 million UUID addresses, and I have yet to determine whether that can be used to generate these UUIDs for Raspberry Pis or not. I don't know enough about it to, but these are it's a block of addresses that are guaranteed to be unique that you actually pay for.
Oh, okay.
And there's no way we're ever going to use 16 million of them, so there's that we could maybe borrow a few, shall we say, and use them for these boards.
Well, I didn't know how you wanted to identify this board, other than if you wanted to pull the I2C devices, and that's how you'll know, or if you wanted to actually store it in an EEPROM. I was going to leave that up for your discretion, and then I would just add it in.
Okay, sounds good. Yeah, it's just a similar. You can do the similar circuit we did on the RF module, because it's a serial EEPROM also, and it's again, these are so cheap. It's like the biggest. It costs more to actually place them on the board and solder them down than either the part costs or anything costs. So it's a 10-cent part and 25 cents to place it on the board. So
yeah, it's good to have that on the board because it can serialize each individual board.
Yep.
You can also flag if there are hardware differences we change an ADC or something like that, but
Mhm.
still have the same function.
And there's another thing, you know, I haven't done this, and maybe this is necessary. I put a dual color LED next to each of the RF module connectors. And the purpose of the dual color, it's driven by the FPGA, and what it does is it's lit up red or green depending whether it understands what the board is that's plugged into that slot. So in anticipation of having many RF modules and many different FPGA images, suppose you plug in, you program an FPGA image that's meant to talk to an HF module, and you plug in a VHF module instead. The board may not know how to talk to that module, but it will know how to identify that it can't talk to it because it identifies it as not an HF module. So then you can light the red LED and you can say, well, I don't know what's wrong, but I can't talk to that board. So you, user, you go fix it.
Yeah.
And so we can do the same thing with the leaf module. We could put a bicolor LED there, and if the FPGA can't figure out what it is that's plugged in there, then we just light a red LED and say, you better plug something in that I understand.
Yeah.
That works.
Yeah. Making a note here.
Yeah, other than everything that I mentioned, that's pretty much all the connections that I'm going to need.
Okay, and so I actually have some spare I/O pins on the FPGA that are really low voltage and not really useful for anything else. And since we have spare connections on this leaf module connector, what I plan to do is have a set of contacts that runs out to the plug-in boards, and they will selectively pull those down or up depending on what type of board it is. And it gives you a coarse ID of what kind of board it is without having to read the PROM. You can say, oh, look, that's a, you know, it's a DLF board, or oh, that's a UHF board, or that's a, you know, you get a class of board, because it's going to be limited to maybe 4 or 5 pins only. So you get 32 different detectable combinations, but it comes for free, so it's can be useful.
Okay.
And also it can be used to detect whether there's a board plugged in at all. So if you see that there's a board plugged in because one of those pins is grounded and yet you can't read the ROM or you can't talk to it, then you can light the red LED and say, it's a fault. I can't fix this.
Okay, that'll work. That'll be good for like contact issues and users who don't see the board in.
Yeah.
Also, there is one more thing. Once we get the timestamp, once we get the timestamping working satisfactory, so then what we have to do is we have to combine the channels into one stream. And
3 channels?
Or
4 channels?
Well, it depends on what the user selects. Let's say that the user selects 4 channels. We need to combine them into one stream in the same manner as the program VTCat will combine streams. I didn't look at the VTCat source yet, but it's all documented in the source code how it's done.
It seems to me the easiest way to do that would be to just grab all 4 channels all of the time and tell the FPGA how you want it formatted.
Well, right, yeah, yes, and what we'll do is we'll look at how VTCat does it, and that's how we'll tell the
yeah,
FPGA.
Because if you capture all of them, then you just be throwing stuff away, and I'm really good at throwing stuff away, so it's pretty easy.
Because
just want to throw it away in the bit bucket.
well, because what's going to happen is that all these channels are going to be sent to the Raspberry Pi through one TCP socket, and then what I want to be able to do for processing, so for the mains tracking filter, that has to be applied to all of the channels, and that's done, and that's also done automatically. That can so the program VT filter can accept a multi-channel stream, but let's say that
it can or cannot?
Can.
Okay.
But
gotta drop off, guys. Good luck.
73, Dave. Thanks.
73.
Have a good night. 73.
73, Dave.
So
we can format it any way you want in the FPGA. The only disadvantage of doing all four at the same time is if you only needed one, say, one channel, then you would only get the data a quarter as fast as you could get it if you're sending only one channel over and over again. Right? Because you basically send one channel and you have 3 dead times.
Well,
so if you actually told the ADCs on the board, shut 3 of them off and run one of it, it's a 4-channel unit, isn't it? So.
Well, that's where I have to look at VTCat a little further and see how it's done, because there are situations where I might only want the E field or one of the B field channels or just both the B field channels. So I want to get all the channels from the Tangerine, and then using his tools, I could break out what I need, send them to where I need to go. If you look at the link in the chat, that's his documentation, and it shows every tool in his tool set. So most of the functions that I want to do will be done in software. The only thing that I want done in the FPGA is the time stamping and the channel combining. Those are the only 2 functions, but the rest are done in his software.
Okay, so when you say channel combiner, you mean you want a 1, 2, 3, or 4 channel stream selectable?
Yes.
So that means, okay. So the question then is, if you select only 1 channel, then you get it 4 times as fast as you would get the data from 4 channels, right? Because if the stream is at the same rate, then if you select only 1 channel, you're going to get it 4 times as fast, or you're going to slow the rate down to 1/4 the speed.
Well, I think what he does, the data is sent in the same rate. He just uses more bandwidth.
Okay.
Network.
Well, okay. Anyway, we can work this out because the FPGA is totally flexible in how we format it. So if you send me all 4, I can throw 3 of them away, or 2 of them away, or 1 of them away, or none of them away. Or you can not send me the data, and I can just format it into the packets in the format that you want.
Right. Yeah. Well, it's the difference between like 192K channel and 4. It'll be sent at the same rate, but it'll just use more network bandwidth.
Okay, but if I'm sending it at full speed at 192K, say I'm sending 4 channels at 192K, so I'm really sending at 1.5 megabits, right? 4 channels? No, I'm sending 768K.
Well, you're going to have to packetize them. Put them in packets and sent over the network.
Over the network, right?
So,
and that's going to be much faster than your 192K. Okay, so never mind. We'll just take whatever we get, we'll packetize it and send it out, however fast we get it.
Yep.
I was envisioning a pipeline all the way from beginning to end, and you can't just put less in the pipeline and have the output still stay the same. So,
right, yeah.
But it's not like that. It's the Ethernet's essentially an infinite sync of data, so compared to the slow rates you're working at.
Yeah, that's the only difference is that it'll just use more bandwidth the more channels that you use.
That's kind of, I mean, when Bill and I sat down and worked out the formats, basically I think we could send you packets of interleaved data, or we could send you packets of 4 streams of separate data. We could do it any way you want, and they'll just be a different packet type. So when you set the stream up, you'll tell the FPGA, the data engine, what kind of data you want. Do you want 4 separate streams? Do you want them combined into one stream, and that format, whatever that is, that the your
VTCat.
VTCat wants, that'll just be that packet type, that stream type,
Right.
a VCAT stream type. And then what parameter might be, how many interleaves do you want? 1, 2, 3, or 4?
Well, see that sort of information is in all of the tools, because each tool can output via a network socket or a named pipe.
Yeah, and see, you're using TCP, right?
Yeah, yeah.
So you're going to have to do that with the Raspberry Pi, because we're not going to do TCP.
Well. No. It'll be TCP from the Tangerine over the network, and then once we get it into the Raspberry Pi or whatever computer, then we set up one of the tools to accept the TCP stream, and then from there it gets fed into other tools via named pipes.
Except that the data engine won't do TCP streams. It does UDP streams.
Oh.
We do self-act UDP control packets, and then all of the data streams are all UDP. That's why I'm saying you're going to have to You're going to have the TCP connection, all the sockets and all that is going to have to be done on the Pi. That's really too hard for the FPGA to do. So that's not going to break anything, is it?
Yeah, because Paul software. So the way Paul software is set up, it's set up by default to do TCP/IP and not UDP.
But if the data engine were to send UDP streams to the Raspberry Pi, and then the Raspberry Pi were to actually use TCP connections to the outside world, those would be TCP, and because the Linux on the Raspberry Pi is going to handle that.
Oh.
And it has the TCP stack, and it handles that fine. But I don't on the FPGA.
Oh, you don't have a TCP/IP stack at all?
No, I have to do my homebrew UDP streaming because I'm just a sea of gates. I'm not a processor.
Well, then in that case, then some sort of utility program will have to be. Well, we could probably use something like NC on the Linux computer to convert.
Yeah, could we just stream into buffers on the Linux computer and then use UDP sockets to read that out? I mean, I'm not a software guy, so this is way above my head here.
Well, the way that it works with Paul's software is that so you have the incoming VLF signal coming in, and it goes from tool to tool to tool via either name pipes in Linux or Unix, or it can go to another computer over the network via a TCP stream.
Okay, but I don't know what name pipes are, so.
Oh, well, it's well,
I mean, I know what a pipe command is like in Linux, if that's what you're.
Yeah, that's.
So isn't that using sockets though? It's
no,
not? Okay.
no, that is using internal memory. Each Linux and Unix has a way to handle that.
But you can do that inside the structure of Linux on the Raspberry Pi, but you can't do that from the data engine. You have to have either UDP or TCP, right? Across the Ethernet port.
Right. Yes. So then since you can't do TCP and we have to use UDP, then we're going to have to either have a utility program or use something like NC listen on a UDP socket and then send it out on a TCP socket.
Okay, that's doable.
I believe so. It should be.
And you're not running at real high speed, so that may save the day.
Well, see, like I could use NC to accept the connection via a UDP socket from the data engine, and then that goes into a pipe. And then from that pipe, I could use a one of the VT programs like VTCat. It'll read from that pipe and then send that stream out to the other tools where it needs to go. Like
Okay, via TCP.
no,
Or maybe pipes again.
yeah, either TCP or pipes, either one.
Okay.
So.
Well, it's getting pretty late for the East Coast guys. You're on the East Coast too, aren't you?
Yeah, and I have work in the morning and homework to finish and all that.
No, but this has been really good information because it really helps to understand how the data is going to be used, how it's going to connect together, so I don't do something stupid that breaks things. Not to say that we still don't have to review it, but it helps me maybe get closer the first pass, and then we can adjust from there.
I mean, if you have some extra free time, look over the documentation for.
I copied that link in and bookmarked it, so.
All right, good. Okay.
Looks like there's a lot to read. Did you send this out on during DCC too, or not? Oh man, this is a lot.
I don't think I did, but there was somebody on DCC that mentioned his live streams. So
this is gigantic. This is VLFRX tools.
Yeah.
Wow. Okay.
So this is a complete tool set that can do anything, like it could do anything you want, basically.
Okay.
So that was a whole idea, to be compatible with this.
Right. And hopefully in my fantasy land, we would become so ubiquitous that he would be writing modules to talk directly to our hardware. Because hopefully,
yeah, that.
But, I mean, let's start out talking to him. So
right.
That's the easiest way. Then it just works.
Yeah, because the whole idea was to use your GPS module and my card to provide the streams that these tools need, instead of the computer with the sound card and the pulse per second plugged into the sound.
I'm going to take a look at that chip that you gave me. What can you give me the name of that chip again? The Cirrus part? The part number?
It's the CS5364.
5364. Okay, I'm going to take a look at that and make sure that we got a deterministic time between the actual clocking of the data and the data stream coming out. Because I think Dave was maybe a little more confident that that was an immutable number, and I'm not so convinced of that.
Well, that's what I wanted you to look over, was that table, and look at the different modes that the SATA deconverter allows. And I wanted you to see if one of those modes might work for you, or maybe you understand it in a way that it could work for this, because there's different modes that you could use, and I don't really, the data sheet doesn't seem to have any rhyme or reason which mode is better for which. It's
well,
just
a lot of the reason they put those multiple modes in there is because of what you're interfacing to might only operate in one mode. So it's not
Oh,
necessarily
yeah, yeah,
which
yeah.
one is better, it's which one will work with the other hardware you have. So
Okay.
in our case, since we have an FPGA, we can do any of them. We're going to try to pick the one that's easiest and best.
Right, right. Which is why that I wanted you to look at those modes and see which one you think feels best to you.
Yeah, I'm thinking the TDM is probably going to be the easiest to implement.
And then you could pick whichever clock, and sampling rate. It like you could do quite a bit with it and set it up any way you want. It's
Yeah.
just if you pick a certain sampling mode, then you have a choice of clock frequencies that you could use. That's all.
Okay. So it's kind of like we can set the clock anywhere we want, and we can set the mode anywhere we want. So what's the best combination? Well,
Right.
probably multiple combinations would suffice. So we have to figure out which one's the best one. Or
'Cause
maybe I could pick multiple ones, but I'd rather not.
Well, I figured for the user configuration, there would be a table hidden in the Verilog that if I pick one channel and a sampling rate, then it picks the clock frequency and
Yeah.
and
And ideally, you don't really need to be able to pick all combinations.
no,
Pick the combinations that satisfy what the software needs.
right,
Okay,
yeah. So
very good.
all right.
We'll let these guys go to bed. I'm ready to go to bed, and I'm in the Pacific time zone.
Yeah, I think I'm ready to go.
So do you have a coat on? Is that a sweatshirt or something?
Me?
Nathaniel?
Yeah, it's just a hoodie.
So is it cool enough there you need to wear a sweatshirt?
Yeah, it's pretty cool out. I mean, it's not terrible in the office I'm in right now, but it's probably about, I think it's supposed to get down to 44 tonight.
Yeah.
Our lows still are in the upper 70s.
Oh, wow. Yeah, no.
Nice. But then it's
So
supposed to be above 100 every day this week. So
Yeah. So, I mean, it is a little crazy.
I still
it's
consider it almost fall though.